right, so here's the lab that I said we would go over in class today. And this is a really nicely set up chart, so you should be able to follow these calculations. Your TR is your retention time for the test compound. So that's just data again. TM is your standard compound, so that's your first peak, your acetone. And your temperature so those are the three columns in this calculation chart that are just data. The rest are calculated. Now, there is no list 7 already on your calculator. So I'll show you how to add it, or you can just skip the Celsius temperature and enter the Kelvin temperature, since you know how to do that so easily on your own, and then your lists just relabel your lists in this chart just so that you don't get confused. So let me clear this, and second memory, clear all of my lists. Okay, so now I can edit my lists. List 1, 1.485, and then 1.475. Good thing we don't have a lot of data, or this would be really, really annoying. 1.530. 1.3. I didn't add the 0 because the calculator is not going to print it anyway. And even though we need it for significant digits, the calculator doesn't need it to calculate anything. Okay, now to do our column 3, we need to go up to the tippy top, and we need to do second 1 for list 1 minus second 2 for list 2, parentheses, divided by second 2 for list 2, and there, that's our K value. Enter our temperatures. Actually, you know what? Let me see. Oops. Before I do that, let me see if I have 7 lists. See, I don't have 7 lists. So instead of adding a list, I am just going to I know this one is going to be 373, so this is 383, 363, 353, and I'm not going to use that column, and this is going to be my L4, my L5, and my L6. That's easier than adding another column. So 383, 373, 363, and 353. Okay, now for my newly labeled column 5, I need the natural log of K over the Kelvin temperature. So I need the natural log of second 3 divided by second 5. Oops, got to change that. That's not going to be 5 now. That's going to be 4. So that would be list 4. And our 1 over T would also be 1 over L4. So column 6 up to the tippy top, and we have 1 over 4 to give us L4. All right, so we've done our chart, and I'm not going to copy it into the data table. So we need to plot natural log of K prime over T, and that's going to be our Y, over 1 over T, which is going to be our X. So we look here, and that means L5 holds our Y, and L6 holds our X. So second stat plot, make sure we have a plot on. And in that plot, we've got our scatter plot. We need our X coming from L5 and our Y. No, I got that backwards. We need our X coming from L6 and our Y coming from L5. And we hit graph. And we're getting a line. Why are we getting a line? Because just like before, we forgot to go into our Y1 and delete that old equation. So we've got to always do that. So now if we graph, we have no graph. So zoom 9, and now we can see it. Okay? But we need to do the linear regression. So number 3 has our directions for it. So stat, calc, we go down to number 4, which is linreg. We tell it the X needs to come from L6. So remember we changed that. And the Y needs to come from L5. Frequency list, we don't need anything. We want to store our equation in order to see our line that we will forget to erase before the next time we do something. We go to vars, y vars, function, and we do it in y1. And then we calculate. So it tells us that our slope is 3348. Okay. Remember we were doing list 6 for x and list 5 for y. So there's our slope. And our slope is equal to delta H of vaporization over R. And R, we know, is 8.31 joules per Kelvin mole. I wrote that really weird. Joules per Kelvin mole. So we've got 3348 times 8.31 to give us our delta H. and we get 27821. But this is in joules per mole, and we usually show these things in kilojoules. And we have, not on this lab, but then we can look up the real value for our substance to compare what we calculated with what it really is. I hope that helps you with your calculations, because your lab is still due next Wednesday. Come see me if you have any questions.